Michelle.
Good morning. I know. Hello, everybody. We are live from the Adler Planetarium. And forgive us for some occasional technical difficulties. This is the first time we've actually been able to do a program from here. I'm going to switch our camera real quick. We'll introduce ourselves in just a second because you probably want to know who we are. And let's get the camera downward just a little bit. Hi, everybody. My name is Michelle. I hope everybody can hear us. We actually can't tell. I'm Michelle. I'm the Director of Public Observing at the Adler, and I have a friend with me today. It's me.
I am Adriana. I am an astronomy educator at the Adler Planetarium. We also have joining us behind the scenes our friend Jennifer, actually downstairs right now where it's a little bit warmer, luckily. So she is going to be our YouTube chat moderator. She is going to help us with your questions and comments. So if you see the Adler's name highlighted in yellow, that's her.
And by the way, Jennifer, do me a favor. Please text me on my cell phone and make sure that you can actually hear our audio on the other end. Because right now we don't have a second screen to be able to tell like we normally do. So we are flying along here because we're gonna have a little fun. We're gonna tell you about a comet. But anyway, while all that is happening, we want to hear from you. So we want to know where you're tuning in from. And we know that we have people waiting. There were folks waiting for us when we signed on. And yes, it is 5 o'clock in the morning in Chicago, and we are here. But while you're doing that, while the Adler Planetarium's doors must remain closed, we're doing our very best to keep our virtual doors open and present some out-of-this-world programming for you. So if you wouldn't mind, when Jennifer gets a chance, she's going to put a donation link in the chat. If you feel as though you would like to contribute, please do. We would very much appreciate it. If you just want to sit back and watch us, that's cool.
You can also help us get more visibility for our shows by hitting like for this video and also subscribing to the Adler Planetarium's YouTube channel. So you can do that right below this video. We're also really excited to mention that we are going to be reopening in March. So on March 4th, 2020, the Adler Planetarium will fully reopen to the public. We are super excited to see people again. We cannot wait, so keep an eye on our social media for any updates and more information about that. And when we're open, come visit us.
Exactly, please do. And by the way, after 25 episodes, I think this is the very first one that Adriana and I get to actually do in the same room. We are so excited. Normally we're doing this from home.
Yeah.
And the last one I did for my driveway. So we are really super, you cannot tell how excited yes, you can. How excited we are to be here. So anyway, Adriana, our viewers may be wondering, why are we here? What are we doing?
So we are tuning in live from the Doane Observatory. This is real. It's not like a background. I can prove it. We're actually here. So we're going to talk a little bit more about where we are in just a minute. But let's see where you all are tuning in from. So I'm going to check. If you see me run to the back, it's because that's where I can see your questions and comments in the chat.
Yep. And Jennifer can hear us loud and clear, which means our viewers can hear us loud and clear. So
Excellent.
We are excited.
Hi, Fred.
Oh.
We've got friends from the South Suburbs, from downtown Chicago, from Mokina, Illinois.
Hello, downtown Chicago and Mokina, Illinois.
In Lakeview.
Hey, Lakeview. That's probably Steve. Hi, Steve. He said he was going
From
to tune in.
Washington.
Washington.
From the Chicago Birds. Oh, hi, Angela. Hung out with us before. Where else? Karen's here in Kenosha.
Hi, Karen. So wait a minute. We have someone from actual Washington State. Is that true? Hey, welcome, Washington State.
I guess.
Holy cow, it's 3 o'clock in the morning where you are. Wow.
Yes.
Extra bonus points for you.
Yeah, a little bit earlier. Thanks for joining us.
Yeah, thanks for joining us, everyone. All right, so we are gonna get started. So I would like to know in the chat if any of our viewers have ever seen a comet before. Have any of you ever seen a comet in the sky? Unfortunately, today we're not going to be able to show you one. It was clear when I got up at 2:30 in the morning, and it is cloudy right now in Chicago. So we won't be able to show you one live like we were hoping to, but a few of you, it may be clear where you are. So you may be watching this video after we record it. So if that's true, we're going to show you exactly where to look in the sky to see a comet if you have a small telescope or even just a simple pair of binoculars. But let us know in the chat. So let's see if any of our viewers, I know some of our viewers have seen comets before. I know, because I know some of our viewers personally. So I want to know, have you seen one? Which one did you see? Where were you? So we would love to know that. All right. Yeah. All right.
So this morning we are talking all about comets, as you know. Comets are cosmic dirty snowballs made of different ices, rock, and dust, and comets orbit the sun. So these snowballs are generally a few miles across on average, and we call the snowball part the nucleus.
That's very true. So, and at this point is where I would seamlessly transition to my part of the script. You guys can tell we are working on scripts right now, but so when a comet's orbit brings that comet closer to the sun's energy heats up the comet's ices and in the nucleus, so in that center snowball part, the nucleus releases dust and gases into a giant glowing cloud that is larger than most planets. Imagine that. The comet itself is not, the cloud around it is, or it can be. We call that cloud the coma. The word coma is Latin for hair. Before we knew what comets were, we named the features that we saw often for how they looked. And so comets looked hairy, and so they were called hairy stars. The hairy part is the coma.
I love that. All right. So the sun's energy pushes the dust and gases in the coma away from the nucleus, stretching away from the sun for millions or even tens of millions of miles. We call that part the tail, which is extra funny in light of hearing about the hair.
You're right.
It's got hair, it's got a tail,
right.
It's got it all.
We tell things in astronomy like they look. So there you go.
All right. So there are billions of comets orbiting our sun. The current number of known comets is just over 3,700. So the number we've discovered is likely far, far fewer than what's actually out there. Many comet orbits don't bring them super, super close to the sun, and some orbits are extremely long, hundreds, thousands, or even tens of thousands of light years, Michelle? Miles. Says you. Okay.
Oh, geez.
That's okay.
It happens.
They're dark and small, so they can be extremely difficult to find. Many comets don't get bright enough to be seen with just our eyes, so it often helps to have a telescope or binocular or something like that to help you see comets.
Exactly. And the one that we're going to talk about, you do not need a big telescope to see it. That's the neat part about this one, why we're going to be paying attention to it, because even just a simple pair of binoculars will be able to show you this one over the next couple of weeks. We are recording this live on December 7th, 2021. If you are going to be looking for this comet anywhere in about the next 2-ish weeks, this is for you. If you are watching this well after that point, you won't be able to see this one, but we know the techniques and tips and tricks that we'll be able to tell you about will help you possibly see future ones. So if you're getting this a little late on the Comet Leonard bandwagon, don't worry, this will still be useful information for you. So, but telescopes come in all shapes and sizes. We happen to have a big one behind us right here.
Yes.
So when Adriana mentions a telescope here, it's like this one right here. This is in the Adler Planetarium's Doane Observatory. That is Doane spelled D-O-A-N-E. It's named for the family who originally very kindly donated the money to help us build this magnificent building in 1977. It is the largest publicly accessible telescope in the entire Chicagoland area. There are bigger ones, but this is actually one that periodically you can actually put your eyeball up to. So the observatory building is located on the shores of Lake Michigan. If you haven't been here, it is the little building that is a little bit to the east of the Adler Planetarium's main building, and that's where we are right now.
Yes. And this is a telescope, right, Michelle?
This guy right here, yes, he is. Yes, actually, we don't know if it's a he or a she. We haven't decided yet. So anyway, it's an it right. So this is our brand new telescope, and the Doane Observatory I mentioned opened in 1977 and was named in memory of Ralph and Lillian Doane. Since 1977, hundreds of thousands of people, if not even more than that, have looked through the various telescopes that we've had here in the observatory. And behind us is our brand new telescope that was installed in January of 2020.
Yes. So with telescopes, the size of the telescope is important. The measurement of this telescope is a 24-inch telescope. That measurement is the size, the width of the mirror, just like Michelle had to move the mirror back here, and that's the width of the mirror. The reason that that's important is because the mirror is what collects light on the telescope. So wider mirror, you're able to collect more light, and if you're able to collect more light and get more light to your eye, you can see even fainter objects more brightly and with more detail. So bigger mirrors reflect more light to your eye, bigger telescope gets you a better view and helps you see fainter objects like comets, if it's clear.
Yep. It needs to be clear out. That is the one thing we can't control is the weather. So anyway, you know what I'm going to do? I'm going to go over to the telescope, to the control system. I'm going to tilt the telescope sideways so these folks can see it.
Yes, I did activate the controller, if that's helpful.
Yes. Oh, you did?
Yes.
Is it working?
It is.
Oh, fabulous.
It was 5 minutes ago.
All right. Well, that is kind of a neat thing. We have the ability to control the telescope using a regular hand controller. So
It's like a video game.
it's like a video game. And let's see. There we go. I am actually controlling it using video controls. So here we go. Put it down just a bit. We have slowed down the movement of it a bit. It actually moves quite quickly, so we have to slow it down. Otherwise, it can move really a little too quickly, and we have to be kind of careful. So I'm going to turn it sideways. I don't think. Can we possibly move it so we can actually see inside? If you think. Let's turn it so that we see a little sideways. I'll move this up. Okay. You take this next part and
Yeah, absolutely. So while Michelle is maneuvering over here, the way the telescope works is fairly simple. Light comes in and reflects off of the 24-inch diameter mirror in the back. So that's on this end. Michelle's trying to show it to you, but we have not tried this before, so bear with us.
Yep.
So light reflects off that mirror, and because of the mirror in the back, because that mirror in the back is actually curved, the light reflects back to a smaller mirror. It condenses and reflects that light in sort of a cone shape to a smaller mirror closer to the front of the telescope.
Actually, I think you can now see all of that.
Oh, light.
There you go.
Like a flashlight.
Yep, I have a flashlight.
We're making it work, everybody.
Sometimes we change our show based on cool things that are going on. So there's the main mirror.
There we go.
See that?
Yeah, it's kind of shaped like a donut.
Yep.
Around that baffle in the middle. So the light comes in through the top of the telescope, hits that main mirror at the back, and then that mirror is curved, so it reflects some of that light back in a cone shape towards this other mirror up here. You can sort of see this thing that's holding it in place.
Yeah, you can see the housing for it. We can't show you that because it's facing this way. So anyway,
Yeah.
Go ahead.
Then that second mirror sends the light back through the hole in the first mirror. That's why it's donut shaped.
Yep.
And that's where you either put your eye or a camera on the back of the telescope. So this means that all of the light that shines into the mirror gets condensed down to fit into your eye. So looking through this telescope is kind of like having a 24-inch wide eyeball. Telescopes are cool.
There we go. And I just sped up the motion of the telescope, so now we can move it
There we go.
a little bit more easily. So there you go.
We're fighting the urge to say now we're cooking with gas. I guess I just said it, huh? Sorry, everyone.
Said astronomy shows for fun. All right, so keep going.
All right. So we've been pointed for a couple of months at Comet Leonard.
Yes.
Telescopes on Earth have been pointed in the last few months at Comet Leonard, keeping an eye on it. And we've been paying attention to it. Comets are named for the person or telescope that discovers them. So the comet that we're going to focus on this morning is Comet Leonard. Comet Leonard was discovered by a senior research specialist at the University of Arizona.
Yeah.
And because my hands are in mittens, it has taken a very long time to turn this page, folks.
It is because
This
right now
last
it's
one-
about 15 degrees out, so it is, and observatories are not heated at all. They're the same temperature as the outside air. And so that's why if you see us going a little slowly at times, it's because we're periodically putting our hands into our pockets with hand warmers because it's pretty cold out right now. All right, so Comet Leonard was discovered back in January. I'm going to show you the discovery or right after the discovery of the comet. So here we go. Give me just a second.
And that comet was discovered by Greg Leonard at Mount Lemmon Observatory in Arizona on January 3rd, 2021.
Yep. And this picture was taken just 3 days after it was discovered. And it doesn't look like much. And you're probably thinking, how in the world did they know that that was the comet? Well, how do you know if something is in our solar system versus out there in the universe? It's just a regular star, background star. It moved. And so this was discovered about a little less than a year ago. You want to tell them a little bit more about this comet?
Yeah, so this is the image. Since that time, since the time that astronomers have found it, they followed it and determined its orbit. What they found is amazing. This is a very fast comet. It's traveling at just over 158,000 miles per hour relative to the Earth. It's getting closer to the sun and will pass closest to the sun on January 3rd, 2022. Oh, that's pretty cool.
Yeah, it was
It's like a year
discovered
after.
literally exactly a year prior to when it reaches the
Closest
point closest to the sun.
approach. Yeah. That's fun. So we call that close point perihelion. Peri means close, and helion is for helios, which is the Greek word for the sun.
Absolutely. And this passage into our solar system is literally the one and only time we're going to be able to see this comet. It normally orbits the sun once every 80,000 years. Yes, that is 80,000 years. But after it passes close to the sun this time around, it's going to eventually leave our solar system completely. It is going too fast to be held by our sun's gravity. And so we will never see this comet again. So this is our one and only chance. And since it was discovered, it has been getting closer and a bit brighter. It is not naked eye visible from anywhere, as far as I know right now, but it is binocular visible right now. But even in small telescopes or parabinoculars, we've got confirmation from one of our telescope volunteers, Bill Chu, that he saw it very easily even last week, and it's a few days later, and it's a few days brighter right now. So we are going to, what are we doing on the chat over there?
Well, we do have one question.
Yes, please.
How often do we have an opportunity to see comets?
Oh, that is a fabulous question, actually. So the answer is, it happens randomly. There are comets, when comets orbit the sun, they do so in different length orbits. For example, Comet Inca orbits the sun every 3.3 years. Comet Halley orbits the sun every 75, 76 years. This comet, if its orbit wasn't as perturbed as it was, would orbit every 80,000 years. And so we need a combination of a comet that will come close enough to us. It gets close enough to the sun to heat up its ices and form that coma and eventually that tail. We need it to come close enough to Earth that it becomes bright enough. It needs to be a large enough comet? So the answer is it's random. We got Comet Neowise last year, which I bet a bunch of our viewers saw. And so Neowise last year was naked eye visible. It was the best comet that we'd seen in about 20 years, 25 years. There was Comet Hale-Bopp, Comet Halley, Comet McNaught, and a few others, but it's just kind of sometimes dumb luck. And this one was brand new. We didn't know about this one less than a year ago. So anyway, so yeah, no clear answer to that. It's just a combination of stuff. And even when the comet is big or bright or it comes around periodically, even sometimes even that might mean it's not going to be a great view. Like Comet Halley wasn't in 1985 and 86. It wasn't a great view. Yeah. Any other questions?
Yes.
Awesome.
Bagel or donut? And the answer is donut. That's all I have to say.
Oh, well, can I add Danish? Can I add Danish? Oh, that. Oh, got it. Bagel or donut. Yeah, donut. Chocolate? Chocolate. Okay, good. All right, now that we got that straight. Okay.
So, we are going to take a look at some images, right? So the cloud in Chicago skies, if you have not heard this already, the cloud in Chicago sky didn't allow us to show you, which is a bummer because when we woke up this morning, it was clear out, but the clouds have moved in as they often do in Chicago. So we are going to show you some pictures taken of the comet recently and stuff.
Yes, so this is a picture available on the Earth Sky website, earthsky.org. We love those guys. They don't know us, but we love their website because it's so accessible and so well written and just very clear information. And they have a community of observers on their website who share pictures. And so this is one of the comet pictures that was taken October 30th, and this is Comet Leonard. And so you can see it passing near, or at least near in front of, a far distant galaxy in our universe. This one, is that? Here we go. This one was taken on November 7th. Again, available on the Earth Sky website. So if you want to go check out these images, and the photographers often included a little more information as well. So there's more information often about how they took the picture, how long, all that stuff. So there's this one, and you can start to get a sense, a little bit of color. Do you see a bit of color in this one? Do you see that? Looks a little green. Yeah. So this one is also available on Earth Sky, also passing in front of far distant galaxies. And then this one, taken a few days later, the tail is getting a little longer, the comet is getting a little brighter, that green color is actually getting a little bit brighter as well. And then this one we really want to highlight because this was taken by one of the Adler Planetarium's star telescope volunteers, who is a fabulous sky photographer, astrophotographer. His name is Bill Chu. And he very kindly shared this image with us. It was taken last week. He went down to the Middle Fork River Forest Preserve, which people who often view Sky Observers Hangout, you've heard us mention that before. It is Illinois' official dark sky park. It's located just outside of Champaign. So he went down there last week, and he was up at about 4 or 5 in the morning and took this picture of the comet near the globular cluster M3. So yay for Bill for taking this picture. It was really cool to see it. So we just wanted to give him extra kudos for sending us this. All right.
Should we talk a little bit more about how people can find them?
Yes, absolutely. That's what you came here for, right?
Yes. So we want to make sure that everybody knows everything they need to know so that they can go out and look for this themselves.
Exactly.
So if you want to attempt to find Comet Leonard yourself, over the next few days, it will be visible in northern hemisphere skies, but sinking towards the horizon. So let's take a look at the orbit of the comet. It'll help that visibility information make a little bit more sense.
Yep, and while I talk through this part, if you want to check and see if there's any quick questions, but this first image here that we're sharing shows Comet Leonard's orbit from above and where the comet is with respect to the Earth and the Sun. As we're doing the program, I set this on the website I went, there's a website where you can look this up. I set it for where it would actually be visible right now as we're doing the program. And if we take a look at the orbit from the side, so let me go to that. All right, there it is. If you take a look at the orbit from the side, you'll see the comet's orbit is angled quite a bit to the planets in our solar system. It is currently above the flat plane of the solar system. Essentially, imagine the solar system as a flat sheet of paper with the planets. It's above that plane right now. It's more visible for Northern Hemisphere viewers right now, but it's going to dive down so that it will be more visible to Southern Hemisphere viewers in the next week or so. And so you'll be able to look for it with binoculars and possibly, maybe the naked eye, we'll see. But it will be visible for Northern and then Southern Hemisphere viewers. So those of you who might be watching in the Southern Hemisphere, you will be able to spot it. So if you back up and take a look at the orbit from even farther out, you'll see that it's angled, again, quite a bit overall to the plane of the solar system. So pretty neat to see. All right, how are we doing?
Yes, we've got a couple of questions. I love that somebody is already suggesting to people that they download the Stellarium app.
Yes.
Suggestion, yes, download the Stellarium app. All right, so we have, is it all just rock and ice? What kind of rock does it vary?
Oh, wow. Oh, that's a great question. The ices definitely vary. Think about the rock as kind of as dust. It's really dust. The dust is left over from the formation of the solar system. So little bits of dusty stuff. And ices can be water ice, methane ice, nitrogen ice, all sorts of ices. And so it definitely varies. The amount of ices vary, the amount of dust varies. But think of it this way. The nucleus of a comet, the external part of it is kind of crusty. So it's this icy crust of dust, ice, and stuff held together. But the interior of the comet is more like the consistency of cappuccino foam. So it's about that kind of fluffy consistency to the interior of it. So yeah, mostly a variety of ices, but the dust is left over from the stuff that originally formed the materials in our solar system.
Yes. Right. Excellent. Also, will there be falling stars after?
I don't believe so with this one, but that's an awesome question because comets are the cause of meteor showers. And so if a comet's orbit intersects the Earth's orbit, then the cloud of material continues to orbit the sun. And if we run into that same cloud of material, that same bit of the comet's orbit year after year, we get a meteor shower. I don't think this one is going to cause a meteor shower, but there definitely have been more recent meteor showers that we hadn't had in perpetuity, and because we happen to run into a new trail of debris from a comet. So yes, that definitely happens from time to time. Just I don't think with this one. Good question. All right, you want to know where to look for this comet, right?
Yes.
You want to know where to look for this
I
comet.
want to know where to look.
We all want to know where to look for this comet. Okay, so, all right, so what is for where we're going to point the telescope or binoculars? I
Yes.
think that's your part, so I'm going to go drive the slide.
So, as for where to point your telescope and binoculars in the sky, we have a screenshot up from Starry Night for version 8. This is the comet's position today, December 7th at 6 a.m. soon here in Chicago. It's almost due east. You probably want to stop looking for it at around 6 a.m. just because it'll be getting closer to sunrise and it might be harder to see in the encroaching wood. That doesn't mean today's the last chance. You can go still over the next couple of days. There's going to be an opportunity. So we don't mean just 6 a.m. today.
Right.
We just mean every day before that time. It's going to be better.
And by the way, that 6 a.m. time is good for Chicago. Your time zone, because sunrise, the time of sunrise is going to be a little different depending on where you are in your time zone. just go out about an hour prior to sunrise, whatever sunrise time is for you. So anyway, go ahead.
Excellent. So we are showing you the location on December 7th. We can show it to you.
I did. We are now on December 8th.
We are now on December 8th, and now we can switch it to December 9th and December 10th and December 11th. Look at it go. So on or a few days after December 12th, that might be when the comet is brightest in the sky. It's also when it's the lowest, but it's worth an attempt if you have clear skies. Yeah, you should definitely go out and try looking for it.
Yeah, absolutely. As for what to look for, you're like, okay, great. How do I know I found it? Well, you want to look for something fuzzy. Simple as that. Something fuzzy in the sky. Stars will look like pinpoints. Comets will look like fuzzballs. And so it will be the brightest fuzzball around. So if you're not sure if you found it, if it's a fuzzy thing, you found it. Okay. You might possibly even see a bit of that green color, maybe. So we're going to now take you through December 13th through 20th because this thing is heading southward, which also means the time of day that you're going to look for it will change. So let me go through. All right. So starting December 13th, and for about a week after, Comet Leonard will be low in the southwest sky about 30 to 40 minutes after sunset. So right now we're here before sunrise. So about December 7th through 12th, go out about an hour before sunrise. December 13th through 20th, go out about 30, 40-ish minutes after sunset. Not too much longer after that because it's gonna set. So you won't have much time to take a look. So it's gonna be interesting to watch it over this time because this may be when it's actually brightest. We don't know if it will be easily visible with the naked eye, so it would be best to try to find a pair of binoculars. And if you're going to pick one day out of those to look for it, try to aim for December 17th. Let me step forward. So this is December 14th. I think they can hear me okay from all the way over here. This is December 14th, December 15th, December 16th. Do you see why we might want to aim for December 17th? Look at that. If you want like the brightest signpost in the sky to try to find this thing, right below the planet Venus. It'll appear to be below the planet Venus, which actually is going to happen in the real sky as well. It's going to pass remarkably close to Venus. But anyway, so if you want that December 16th, 17th, 18th time frame, look for Venus, look below, look for a fuzzy thing. There you go. All right. I'm going to go December 18th. All right. December 19th. And December 20th. Okay. So if you can't remember all that, don't worry. Just refer to your friendly Sky Observers Hangout recording. It will be available on YouTube after a program is done. And you can use this as a helpful guide. But yes, download Stellarium or use an app on your phone and look for Comet Leonard. And yeah, hopefully you'll find it.
Yeah, we are looking so. Yeah. So if you want more information about where to look and what to look for, Jennifer is going to put a couple of links into the YouTube chat with more information about Comet Leonard. One of our pals at the Earth Sky website, and the other is from the Sky Lab, which includes generating a sky viewing chart for where you are.
Yep.
Look for the link on that page titled Go to Interactive Sky Chart.
Exactly. So yeah, because depending on where you are, you may need to look in a slightly different part of the sky. Not drastically different. It's not like you're going to look to the southwest here and to the north someplace else. It's not going to be that different. But it is helpful to generate one of those sky charts just to be sure that you're looking in the right spot. Because again, it is a fuzzy blob. And it's not necessarily going to be humongously bright. It's not going to be as bright as Venus. But it'll be interesting to see how bright it gets. And by the way, if you're wondering what kind of binoculars to look for, 10 by 50 binoculars are what people are recommending right now. So the 10 refers to the amount of magnification. So the binoculars magnify 10 times. 50 refers to the diameter of the main lenses of the binoculars in millimeters. And so 10 by 50s are what you want to aim for when you're looking for binoculars. It'll give you the right combination of magnification and showing the comet bright enough that you can see it. But if you have something even a little better than that, that's great. How are we doing?
Good. James says, I can see it now. By 7 binoculars from West South Carolina, distinct hazy glow in oceans.
Nice.
Very cool.
Nice. So wait a minute, is it actually seeing it like literally right now in South Carolina? Like absolutely this very second? Tell us. I want to know. I want to know if you are actually seeing it this very second, or if you saw it like a little while ago. Today, I want to know. That's cool. All right.
So the tail, James says the tail is invisible, the long axis roughly east-west.
Yeah, that's exactly right. And that oblong shape, you're seeing the coma and the tail, a little tiny bit of the tail. You may need to be under a really dark sky to see more of the extended tail. The problem with not really a problem. The thing you have to remember with a comet is it's not uniformly bright. The head of the comet will be brighter than the rest of the tail. So don't be dismayed if you don't see an extended tail. It has one, but all those pictures that you're seeing are essentially multiple second exposures. Bill Chu's picture we showed you earlier was a single 30-second exposure. Your eyes refresh every 30th of a second. And so you're not gonna get the amount of light in to see that dimmer tail, but you'll see the fuzzy head part. So give that a whirl. All right, how are we doing?
Good. We had a question, but then somebody in the chat answered it, which I love.
We love it when you do that.
What does it look like? Why does it look like it's traveling in the direction of the tail? Somebody answered, I believe the tail always goes away from the sun, not following the direction of the comet. Yes.
Exactly right. Exactly right. And it's also perspective. It's how we're seeing it in relation to the sun as well. So sometimes we see the tail might not be as extended because maybe the tail is pointing more at us. So yeah, the configuration of how we're looking at it will affect how it looks as well.
Very cool.
Cool. We love it when you guys answer everybody else's questions.
Thanks for helping each other out.
It makes our job easier. All right. We good?
Yeah.
Can we show them a little history? Would you like to see a little bit of history? We want to show you somebody really awesome. We've talked about her before, but she's always worth talking about. I think so too. Oops. Hang on, give me a second. All right. Fans of Sky Observers Hangout know that for most of our shows, we like to highlight something from our Adler Planetarium historical collection, which is amazing. And we have instruments, books, works on paper, and all sorts of stuff. And we call this segment Collections Corner. And for today's Collections Corner, you get to introduce this wonderful lady.
We are going to turn our attention to astronomer Carolyn Herschel. Caroline's brother William is best known for discovering the planet Uranus, but Caroline played a huge role in his sky investigations. She became a respected astronomer in her own right.
Carolyn Herschel, or Caroline, we're actually not quite sure what the correct pronunciation is, so I say Carolyn, Adriana might say Caroline. If someone knows,
We're talking about the same person.
Yeah, we're talking about the same person. If anyone actually knows the absolute correct pronunciation, please let us know. We would like to make sure we're saying it correctly and respecting her. She was the first woman to receive a salary as a scientist. She was the first woman in England to hold a government position. Let that sink in for a second. That's pretty awesome. In all, she discovered 8 comets.
So Caroline lived to the age of 97, and the year before she passed, there was a drawing made of her. So we're taking a look at that drawing, Michelle.
Yep, sure.
This is her in the year 1847. She has glasses around her neck and her arm is resting on a book. You can see there. She's pointing to a drawing of the solar system.
And that drawing includes the orbits of 2 comets. And they are a little hard to see, so I'm going to highlight one of them for you. Excellent. There we go. And I've highlighted one of those comet orbits. Now this drawing celebrates Carolyn's amazing achievements to discover 8 comets in her lifetime.
So she held the record for the number of comets discovered by a woman until the past few decades, when she was surpassed by another Carolyn, and that's Carolyn Shoemaker. Shoemaker. It's just Shoemaker.
Yes.
Carolyn Shoemaker discovered 32 comets in all and hundreds of asteroids.
32. 32. Can you imagine?
Yeah, that's quite a few. So she's among the world's most prolific comet finders. We lost Carolyn a few months ago at the age of 92. So we're happy to take a moment in Sky Observers Hangout to celebrate the lives and accomplishments of both Caroline and Carolyn.
Yep, and you may know Carolyn Shoemaker from Comet Shoemaker Levy 9, which is the one that impacted Jupiter in 1994. So that's how I first learned about her. So
I've
yes,
heard that name before.
yes. So yeah, that was the 9th comet that was discovered by the team of Jean and Carolyn Shoemaker and David Levy. So, all right. Any other questions before we move on? Hope you guys are having fun. We're having a blast. It's cold in here, but we're just having fun doing this from our actual observatory. So anyway, yes, I think we are nice. I love it when that happens. Okay, so we are almost done for today. A lot of people want to know when the next comet is, so you'll probably want to know, what are we keeping an eye on? So do you want to tell those folks a little bit about what we're keeping an eye on?
Yeah, so it's a little bit of a hard question to answer when the next comet is. It's difficult to predict how bright a comet is going to get, whether it's going to be visible or not. Because how bright it's going to get depends on factors like how much of those ices and gases a comet actually releases into space, combined with how close the comet is to the sun, combined with how close to the Earth the comet is. So there's a lot of stuff at play. There are a couple of comets that will get close to the sun in 2022 that we are going to keep an eye on. Neither of them are expected to be as bright as Comet Neowise last year.
No, but maybe binocular visible. So we'll see. So the first one that we're keeping a close watch on is Comet Pan-STARRS, P-A-N-N-S-T-A-R-R-S, Pan-STARRS. It refers to the telescope camera array that searches for these things. Pan-STARRS C for comet / 2021 O, as in the letter O, 3, which will swing by in April and May 2022. Another is Comet Pan-STARRS, P-A-N-S-T-A-R-R-S, Pan-STARRS C / 2017 K2. And K is the letter K and the number 2, which will swing by in July and August 2022. By the way, if you're wondering where these strange names come from, C refers to comet, then there's a slash, then there is the year that the comet was discovered, and then the letter number combination refers to which month and which half of the month they were discovered, and then in what order. So Comet Leonard is C / 2021 A1. So that means it was discovered in the first half of January 2021, and it was the first comet discovered in the first half of January 2021. So A, first half of January, 1, first comet discovered in the first half of January. So C 2017 K2 was discovered in whichever half of the month the letter K falls into. And it was the second one discovered then. Right?
It's just me trying to figure out which month K is. Sorry about that.
I almost tried to do it. Let's see, wait a minute. A, B, so that's January. C, D, February. E, F, March. G, H, April. I, J, May. K, so it would have been the first half of June. So second comet discovered in the first half of June 2017.
Thank you. That's actually useful. I did not know about that. Thank you.
And yes, we both were using our fingers to do that. Totally fine. Do whatever you gotta do.
It's the easiest way to do it. No shame. All right. So we'll wait to find out to see how bright those comets are going to get. In the meantime, Michelle, you have a story about a comet that was not maybe what you expected it to be.
No. No, in 1985 and 86, I was in junior high, 8th grade, and I was trying to find Halley's Comet. Now, Halley's Comet in the 1910 apparition of that one was pretty bright, and people remembered that one for decades. This last one, just not great, and it just wasn't quite as bright as maybe the name would let it appear to be. I searched and searched. I got up before sunrise. I searched. I got my binoculars out. I never saw it. I know that some of our viewers probably did, but I did not see that one. I did come here to the Adler in order to learn more about it. I definitely did. We visited, but I did not get to see that comet.
As somebody who learned about Halley's Comet from the show Hey Arnold, where they make a huge deal out of seeing Halley's Comet, it's very exciting. I was very disappointed to hear Michelle's story.
I love the connections that people make with TV shows and all that.
I was like, it's supposed to be a big deal. I learned about it on Hey Arnold.
Fabulous.
What's going on?
That's fabulous. Now, I did see Comets Hyakutake and Hale-bopp. Those were great. Those were fabulous comets. And Neowise was right up there too last year. So that was pretty awesome. All right. We're just about ready to wrap up, I think.
I think we are.
Should I check to make sure we don't have any last minute questions before we sign off?
Lots of people talking about how to pronounce Caroline.
Oh, yay. Is there a
Greetings from Scotland, Caroline, and England is pronounced line rather than lit. Thanks, Susie.
Nice, thank you. Well, see, that was the one thing we weren't sure about because she lived in England, but she was from Germany. Do you pronounce Caroline differently in Germany? Is Caroline is that an Englishized version of a German sounding name? I really don't know. That's where I got really confused. And it was over 200 years ago, which doesn't help.
So, all right, let's see what else we have here. Somebody else answered the question too. I love when that happens so much. Was Caroline Herschel the wife or sister of William Herschel, the astronomer's sister? Yes,
Sister.
you got it. Everybody who answered sister.
Yeah, they lived in the same house and she helped him a lot with his observations. When he got married, she did live with them for a short while, but she moved out after William got married.
Yes. Excellent. I think that is all of our questions, except for people saying thank you. Which thank you.
Thank you for joining us at 5 o'clock in the morning Chicago time, 3 o'clock in the morning for our viewer in Washington State.
Yes.
Oh, by the way, one other collections item we almost forgot to mention. We have a telescope that was made by William Herschel as part of our collection. It is on display at the Adler when we reopen on March 4th. When we reopen March 4th, 2022, please come see it. It's really awesome to see something that literally William Herschel, and I'll betcha Caroline also, had their hands on. They built this thing, at least William did, and I'd be shocked if Caroline didn't help with that. So you can see the telescope and the mirror is taken out of it. So you can see the metal speculum mirror that's next to it. I think it's a speculum mirror. So anyway, so next time you visit the Adler after March 4th, please come see it and give a little tip of the cap to Caroline and her fabulous comic work. Right?
Yeah.
Well done?
We are all good. All right, friends. So we hope that you can join us for our next episode of Sky Observers Hangout. It's going to be on January 10th at 7 p.m. Central Time. Yes, a normal hour. So it's going to be called the Northern Lights. We're going to give you some tips and information on how you can see an aurora for yourself.
We are not planning on showing an aurora that night.
No.
That would be great, but we can't plan on that, not this far.
Yeah, and we will talk a little bit more about why that is not a possibility.
Exactly.
As a reminder, I'm going to tell you again, we've told you like 5 times, but here it is again, the Adler Planetarium is reopening on March 4th, 2022. That's a Friday. We hope to see you there. Start making your plans to join us at the Adler, and if you happen to run into either one of us at one of our in-person programs, come say hi.
Please say hi. Please tell us that you watched us on Sky Observers Hangout. We would love to know that. And we would love to hear anytime you are interacting with the sky. If you get to see Comet Leonard, please tell us. If you see anything neat in the sky, tell us. We would love to know. On the ending slide that I'll share in just a second as we're signing off are all of the Adler Planetarium social media feeds. Please use any of those to share your observations. And we truly mean it. We love to know that. We have a channel and we use Slack, and we internally to communicate with each other. And we share all sorts of cool things that we see on Adler social media feeds. And when you've done something neat or you shared a picture or something, we often get to see that from our social media team. They love sharing that with all the rest of the staff. So it really does get looked at. So use the hashtag #LookUp, all one word, look up, when you're actually looking up and connecting to the sky.
Yes, excellent. So thank you so much for joining us and for, as usual, supporting our programming. We genuinely love sharing this time with you. And as always, we would love to get some feedback from you. So Jennifer's going to link a feedback survey in the chat. It is short. It is easy to fill out. If you have already filled it out, you can go ahead and fill it out again, because we love tracking what we can do better and continuing to improve the show as we go. So any kind of feedback or information is useful, even if you've done it already. And if the chat closes before, we will have that feedback survey also linked in the thing in the bottom. You know, the
description. I did put it there. It is there. I put it there.
It's there.
It is there right now. So you can just click that.
Excellent.
All right. Don't forget, if you don't already subscribe to our YouTube channel, please do. We have great content. We would love to have you back to watch us for our next episode of Sky Observers Hangout. In the meantime, thank you for joining us, everyone. Please keep looking up and enjoy your rest of your day. Good night.
Good night.
And good morning.
Happy comet hunting. I hope you see Comet Leonard.